Uh, so can you hear me, my voice?
Yes.
Yes, good. Okay, I'm in Changwon National University, so I just wonder what topic is good for you guys after your suggestion. So I just select my topic. So my research topic is intelligent vehicle system control. Sorry for my voice. My voice is a little bit not good, but please understand me. So let's start my presentation. So first, I will introduce myself. My name is Juhui Gim again. My I just work in the like MCD in University Michigan in USA before came here. So and my research interest is optimal control and estimation for autonomous vehicles. So that's why I just select my topic for this presentation. So before discuss about my topic, I just let you know what's the trend in global for automotive. So we can discuss like a four big topic for the current trends in global. So first one is population growth. So you guys already know the population is really grows very fast. So that's why it also increased the mega city. So sometimes some city is a little bit small, but lots of mega city is really increased, like New York or Lima or Korea too. Also, generation is changed because of the birth rate. Actually the Korea birth rate is very low. That's why the generation is becoming older. So that's why the generation is changed too fast. And then last one is eco-friendly. As you know, the global warming is very serious problem. So that's why we just pursue the eco-friendly technique. So it affects a lot of things to automotive. The first one is safety and energy congestion too. So these are the like related the like population growth and the megacity growth too. Also the aging, that I already say to you, the generation it changes. The both the like a three factor is very combinate each other. So that's why the automotive should like prevent to that kind of problem by this pact. So that's why we can check the trend of automotive. It like change to be the intelligent. So that's why my research topic is intelligent vehicle system. So the automotive like a trend can be categorized into two parts. The first one is for unmanned, and second one is for energy. So for unmanned is like we pursue the automation and connected. So automation is like we can make the car to be the smart. So like for example, optimized for you, like optimized for vehicles, and optimized for vehicle trip. And last one is the adaptive. So adaptive means we adaptive to like various environment. And second keyword is connected. So connected is we can get the data from the other vehicle or other infrastructure or even pedestrian. So for this one, so we can get the new data channel and new information. So it makes the new opportunity. And then the second keyword is energy. So energy, we can make the electrification of the vehicles. So like we change the intra combustion engine to hybrid electric vehicles and to uh, plug in hybrid electric vehicle and battery electric vehicle, even pure self electric vehicles. So for this one, we also have the like a lot of issues for this problem. So actually, for automation and connectivity, so actually we have the lot of sensor is weak to weather or driving conditions. Actually, this sensor is the LiDAR sensor in the snow data. So as you can see, there's a lot of snow data interrupt a lot of object point cloud. So that's why we have to signal processing to like remove the like this snow data. Also, the autonomous vehicle, like if you make the smart, the autonomous vehicle can be weak to abnormal conditions. So like actually this figure is in Korea, but I will explain this one. So this is a very famous accident. So it's made by Waymo. So in the Waymo, like a Google, so there is a accident. This is a Waymo car, and this is the bus by the human driver. Okay, can you hear me? So a little bit like a voice.
Yes, we can hear you.
Okay, okay, good. So, like a Waymo car, the autonomous car hit the bus because the autonomous speaker cannot recognize bus exactly. So in this case, we like autonomous speaker also figure out the human-driven vehicle how to act like that. So in summary, the autonomous vehicle can be required the robust strategy in arbitrary driving conditions while acting like a human driver. And for electrification, so lots of energy system, even though we change to the battery system, for example, the battery is not sufficient efficiency. So that's why we figure out how to improve the efficiency as like ICE. Also, the charging time is very too long, and the charging infra is very inefficient. So that's why for electrification required to improve eco performance for the efficient control. And then also, actually, AI is very popular for the every build. So AI can be help the future vehicle for unmanned and for energy. So my research is related to that kind of problem. So that's why my lab is also named is Intelligent Vehicle System Control Laboratory. And this laboratory is work for optimal control and estimation for intelligent vehicle system and plus AI. And we have the three PhD candidates now and seven master candidates and one intern. And so we, for 11 students, we study about to solve this problem. And then detailed research is we can classify the four parts. The first one is weather levels perception. And second one is the state estimation of the autonomous vehicle. And third one is dynamic system modeling. And last one is vehicle control for making intelligent system. And the really some research can be like a really big part. For weather levels perception, we have four parts: the AI and Kalman filter integrated load surface detection, and AI-based virtual data generation, and LiDAR signal model-based noise filtering, and the load side unit-based perception. As for state estimation, I have a five research topic. And the first one is load profile estimation using onion IMU sensor. And second one is the AI-based battery SOC estimation. And third one is brainwave I'm really interested in the brainwave in this case. So brainwave-based human likeness extraction and a landmark-based vehicle localization. And last one is just a terrain-based vehicle localization. And for dynamic system modeling, I have a lot of research built. The first one is driver interaction modeling for abnormal conditions, and traffic system modeling too, and AI-based excavator modeling, AI-based thermal system modeling, and AI-based expert skill modeling. I will introduce this one detail later. And then AI-based battery modeling and osmosis phenomena modeling. And for vehicle control, uh, the first concept is the vehicle tripping control for impact. And second one is AI-based hybrid electric vehicle power management control. And the rapid optimal control for accelerating hybrid electric vehicles, and risk-based collision avoidance and optimal control for fuel cell electric vehicle power management. So the black character is like the current research topic, and the gray is already passed. I already finished this topic, so I will focus on the black one in this presentation. So for weather robust perception, I just show the really black line. The first one is AI, computer-based dry overload detection, and second one is high-quality virtual image generation, and LiDAR signal model-based noise filtering. So actually, the introduce all of topic is good for you guys, but I will just select some topic later. The second one, state estimation. So first one is load profile estimation using only an IMU sensor. And second one is brainwave-based human likeness extraction. So we have the like a simulator, and then we extract the brainwave, and we just the signal analysis. And third one is AI-based battery SOC estimation. And for dynamic system modeling, so I just make the driver interaction modeling. And the second one is traffic system modeling. And third one is AI-based excavator modeling. So excavator is like this one. So we just design the excavator and we train using the deep learning one. And then the AI-based expert skill modeling. So actually, we have the like a lot of manufacturing process for the vehicle system. So, but in this case, we need the expert skill. But actually, the expert is already like become old, and employment rate is also decreased. So that's why we just design the AI skill to resemble the expert skill. And last one in this part, the AI-based integrated thermal system modeling for electric vehicles. And last topic, the vehicle control. So first one is vehicle tripping control for impact. So in the when the vehicle spin out, we just control the trip. And then the AI-based power management control for hybrid electric vehicles. So we just make the data. How can the train the AI model, and then design the AI module to uh, to predict the power management control. And the last one is I'm also the like a solely researcher, so just I focus on the rapid optimal control for accelerating HEVs. So I will introduce now the detailed topic. So first one is this one. So actually, we have already lots of the perception technique using the AI. But usually AI-based perception is very vulnerable to weather or dust condition. So in this case, it's a heavy rain. The wiper is also interrupt the imaging. And in the dust condition, and also it's kind of that kind of dust condition. So low performance for driver load detection, it can cause the like a low safety. So that's why we require a robust driver load detection algorithm against weather or dust condition. So actually, I already say to you guys, we have like a very popular AI algorithm. We call it like a mask lesion convolution neural network. So it detect we in this imaging, this technique detect like a box, and in box we just focus the data more, and the result is load very well. So I just use this mask RCNN into the real image in sunny day. So in sunny day, this skill can detect very well. So like a blue one is the leisure, the detected one. So it's detected very well. So but I also adapt to the rainy days. But as you can see, the blue line is sometimes disappear and sometimes it miss the load. So it means the Mascard CNN, the very popular uh, AI algorithm, cannot detect load, drivable load in rainy days. So we first method is we improve the existing AI algorithm. So we just integrate other AI method in the same popular mask RCNN framework. So this is the original mask RCNN. This is the like we propose the neural network one. So sometimes it miss, but it also sometimes miss drivable load, but it's better performance better than the original one. But though still it has the poor performance sometimes. Okay, so that's why we integrate the using the Kalman filter. So we design the Kalman filter and we integrate the AI result to the Kalman filter. So that is we call the history-based compensation. So I just like ignore the really detailed skill. Just this is the like a big concept of the proposed method. So this is the proposed method in rainy day. Okay, it's better performance compared to the like a previous one, like using only AI technique. So when we add the Kalman filter to the AI, so Kalman filter can compensate AI lesions. So that's why this lesion can like a much more accurate result in rainy days. So this is the like a frame, just a one frame of the lizard. So first one is benchmark means the original mask RCNN, and second one is the advanced mask RCNN. It means we change the sub network, and so third one is proposed. It means the AI plus Kalman filter. So using only AI, it means the load, drivable load area, but the proposed method, we detect the load very well. So we also check the IOU for this legend. So a lot of frames. So this is the original, this is the advanced, this is the proposed. So you can see the average and standard deviation. the average is really increased, and also standard deviation is very increased. So it means our algorithm detects the load, drivable load very well. And next one is I will introduce the high quality virtual image generation. So we already see the this background. The poor performance of AI is very affect to the safety. So that's why we just design the robust drivable load detection algorithm. But still, AI algorithm is not a good performance. Does not have the one. So it's still the vulnerable to the adverse condition because of the lack of data set. So because AI is really affect to the data set, but usually we have the like a huge uh, amount of the sunny data, but the rainy or sunny snow data is very lack. So it means that we have the data imbalance. So using the imbalanced data set, train the deep learning technique. So if we get the like a very high accuracy, it means the sunny day has the very good performance, not the snow or sunny day, because the data is very lag. So it means we require many and various data set, like huge amount, and like a balanced data set. But usually we have the very like a many dry weather, but weather and snowy day is very less. Especially in Changwon, we don't have the snowy days, so that's why we cannot get the snow data. So how can I get the snow data? We make the deep learning data to generate wet or snow data using the dry data. So it is our suggested solution. So we just want to make the wet and snow data using the dry data using image to image translation technique. So popular image translation technique is cycle gun. The cycle gun is changed to horse to the zebra one. So it changed to the domain. So it means we change to dry to the wet condition or dry to the snow data. Also, we have the like a popular image translation in the deep learning field, the stable diffusion. So stable diffusion is also generate the image. So if we give the text like a high snow scale or high snow field like that, the deep learning generates like a high snow load data. Using this one, so we just make the virtual image generation part. So first, we change the picture translation using the cycle gun. And second one is stable diffusion. But the special one is I just attach the learning balance in front of the cycle gun. The learning balance means actually the cycle gun doesn't have the learning balance technique. So if the dry weather has lots of amount and the wet weather is very lack, very small one. So in this case, so the original cycle gun is uh, like a decrease the image quality. So, but in my case, I just make the loading balance scale into the cycle gun. And also the stable diffusion is the changing the image, total image. So we can get the like a unexpected the images for the when we use the stable diffusion. So that's why we just develop the partial stable diffusion. So in front of the stable diffusion structure, we just use the mask Arsen and lizard, and we just adapt the stable diffusion only in the partial area. So the detail I just deleted one, so I will just show the result. So this is the ground truth. It means the dry weather, near dry weather. And this one is we already made. We just make that. This is just only just the virtual image, not exist in the real world. So these two, one is stable diffusion. So when we text prompt, okay, we just want to make the wet asphalt and cloud sky. And we adjusted the strength is zero point 0.4 and this one is 0.7. Then stable diffusion make the generate the image. So as you can see, the for wet asphalt, so this load changed to the like a little bit wet, and the weather is like a little bit gray, but it's very weak because the strength is very low. So that's why we changed the strength is a little bit high. Then the sky is like a little bit gray, like we get the cloudy sky. But the also load is very wet. It is not unexpected like a value, but we cannot control the like a partial picture because the stable diffusion just change all picture like using the based on the strength. In this figure also change a little bit, but we just improve the strength, then the load is really changes. The serious one is even even we just of the strength the building is the really changed to like animation. So we don't like this one. We don't like this one. Also, actually, there is no character, but if we increase the strength, the like a strange character is generated in the load. The like a, what is the cool way like this one. The original cyclogon. This is the result of original cyclogon. So original cyclogon is just a transform to the like uh, of the picture. So this one is cloudy sky. So but this is cloud sky. Also it's very good. But in if there is some object, you can see that this quality is very low. Also, this one, this one is original one. This one is the generated one. The little bit the quality, image quality is really not good. And then we want to get the wet asphalt, but it is not the picture transfer the picture very well. This one is proposed one. Okay, so we can check the very good performance. So the weather is like a change to gray, and the road is like a little bit wet compared to the cyclogon, original cyclogon. And then building is not disappeared like a well, like a compared to the stable diffusion. Also, this picture, also we can get the like a gray sky and little bit wet compared to the cyclogon. And then also we conserve other picture like not related to the weather is preserve compared to stable diffusion. So other picture are also same. Also, we want to make the snow data. So this is the like real data and the stable diffusion and cyclogon and proposed. So we want to make the snow asphalt. So in that case, there is no snow because cyclogon does not transfer the picture very well. And the stable diffusion, if we use the very low strength, the picture are not generated very well. But if we increase the strength, of course, okay, the snow is increased, lots of snow. But there is no object, so this plate is disappear in this region. So in building is disappear in this region. However, so my proposed one is okay, preserve the building and they make the snow data well. Also, it preserve the object very well, even the car, and then we make the snow. And this one too. So we make the snow a little bit, and we also make the snow like icy snow. Also, we change the night sky. So as you can see, the result of my proposed method generate the wet asphalt and night sky well compared to other stable diffusion and cyclone. So I can generate the virtual images very well compared to the stable diffusion and cyclone. And also it is a very realistic one. So also the quality, image quality is preserved. So that's why, okay, if we make the virtual image and using the virtual image, training training the uh, deep learning model, maybe we can get a more accurate result. And third topic is LiDAR signal model based noise filtering. So LiDAR is very popular sensor for the autonomous vehicle. So it detects the surroundings using based on the point cloud. So it is very strong in night because a light is always exists independent on the like a lightning condition. So in night we can predict the object. So that's why the lidar is very essential sensor for autonomous vehicles. But the problem is in the snow. I already say to you guys in introduction. In snow, that is the result of the lidar sensor measurement, but also it detects the snow particles. So this is actually object. This is object, but there are lots of snow point cloud nearby this object. So, but the LiDAR point cloud, this is semantic the information. So it means we cannot distinguish which point cloud is the snow or pearl. Okay, so that's why we designed the LiDAR sensor signal. So we just design the extinct factor depending on the weather conditions. Also, we design the like a extinct factor, like a jitter one, or like a missing point. We also design the pattern. I just I just ignore this one. Just so this is the big concept of the my proposed method. So first one, we just snow filtering using the LiDAR intensity. So we just because the snow has the low intensity because the snow particle has very thin and the white one. So that's why the intensity is very low. So depends on depends on the intensity, we can like remove LiDAR points a little bit. So this is the result of the like intensity based remover one, and then we just also uh, remove the snow picture. So we just the snow is the like a randomly distributed. So that's why the using the density property we can remove the snow picture a little bit. So but still, we have the, like a lot of red one. It means the snow particle. So I already designed the snow signals, like using this concept. So adapt this result, and I remove the snow particle and this result. So this is the we detected snow particle, and this one, the blue one is okay. We figure out which point cloud is the object one. So that's why this is the final result. So we can disappear the snow particle, and we preserve the object point cloud. Then we can get like a more detailed result to detect object using the LiDAR signals. So that's actually the figure we cannot distinguish which one is good or not. So that's why we just suggest the qualitative result. So this is the low data, and we also other like a popular main snow particle filtering technique. And this is my proposed one. So this is the snow. This is the snow one. This is the object. The TROR is the very popular one. So, but it just disappear even the object. And LIOR is nowadays is very popular because it uses the also intensity property, but it is not. It is still has the snow particle, as you can see. Like this one is actually snow particle, but we just remove all snow particle and we just preserve the real object. Like in this case, even this point is a real object, but DROR is already removed the object point cloud. But our one is we just preserve that. So just we check the also the time. So TROR and LIOR, we the uh, average and max and minimum time is very very higher than my proposal. So my proposal has the good performance in the like a low computing load. Also, after the filtering, so we detect the object using very simple algorithm. So TROR is already removed the real object, so that's why the real object cannot detect very well. So this is the ground truth, but this is already disappeared. So that's why there is no point cloud, so TROR cannot cannot classify the object. LiOR case is preserved the more object point cloud, but it still has the snow point. So sometimes it misses the point cloud like that. So this is actually so in the point cloud. How can I say this one? So uh, in 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 here, lots of actually object, but it already include the snow point. But my proposed one, is similar to ground truth. So that's why I also checked the precision and liquor one. So precision and liquor, so my result has higher performance compared to the when we use the DRR or LIRA. So it is really high value for this one. So that's why the ILS, I just my summarized one. I just developed a very good performance noise filtering for LiDAR point cloud, compared to the very like a popular DROR or like a methodology. So I finished this one. So if you have any question, please let me know. I just realized that my voice is a little bit not good and my speed is a little bit fast. But please when just ask to me whenever you want. And second topic is state estimation. So it's more related to the autonomous vehicle. So first one is load profile estimation using a neon IMU sensor. So IMU sensor is like we can get the acceleration and the angular velocity compared to the like a big the load surface. So it means we can estimate load surface, load information using the IMU sensor. So But actually, the using estimating the load information using only IMU sensor is actually impossible because of the observability. So that's why uh, the existing research is focused on the using the additional sensor like a camera or lidar like that, or ignore they make the they make the model very simply to preserve observability. For inclination, it also as the GPS information or very make the model very complex. But my proposed method is load elevation. We just estimate the both load elevation and load inclination together using only an IMU sensor. So this is my proposed one. So we just design the model, and we also use only IMU sensors. So that's why we just calibrate IMU sensor signals, and we also make a sensor bias model. And then actually using only IMU sensor is like a that is unobservable. So for the observability, we just design the virtual measurement model. So this is my suggested one. So also I tested using the data we get the like a M city. So depend the like a two we just use the two different vehicle and uh, different speed conditions. And uh, this is the result one. So this is the in the distance domain. This is the estimated result on the displacements. It means the load elevation changes. So regardless of the peak speed and peak time, so we can get the more exact we have the same page of result for the load elevation change in front at the front left tire, front right tire, and front rear right tire and rear left tire. And for inclination, road slope is also say we can get a similar pattern. So it means we develop the load profile observer regardless of the big speed and big dynamics and big time. So using this one, maybe we can apply the vehicle localization using terrain information, and also we can reduce the light comfort. And second one is brainwave human likeness extraction. So actually, autonomous vehicle required human-like driving for safety on public road because we just the autonomous vehicle and the human-driven vehicle can be coexist. So human-like means is the autonomous driving vehicle it can be implement communication like a human driver with the other vehicles. So if we want to lane change, we sometimes have the interaction to other vehicles, even in unprotected left turn. Also, we just have an interaction other vehicles. So that's why we just want to make the which one is make the human likeness. So that's why we just figure out which factor affect to the human likeness using the brain wave. We call the EEG signal. So using the EEG signals, we just figure out which factor is affect to the cognition or decision making uh, by the vehicle drivers, vehicle behavior. So we have the simulator and we driving, and we measure the human EEG signals, and so we just design the scenarios, the braking scenarios, and and then we just get the EEG signals. And this is the signal analysis. So we just first one is we just compare uh, the frequency domain signals compare in the smooth braking or aggressive braking scenarios. And also we just figure out which one is different in the spectrogram domain. So this is the like a qualitative value. So this one is smooth braking. And this one is the aggressive braking. So as you can see, smooth braking has the higher value compared to aggressive and smooth braking. It means depends on the braking scenarios, and the each signal has the big gap. So it means what I say mean is that we can figure out the big breaking scenario depending on only each signals. So if we see the each signal, okay, we don't need to the peak break behavior. Just we just classify which one is smooth and which one is aggressive in the each signal domain. So, and sorry for that. Maybe, okay, so last one is in this field is AI-based battery SOC estimation. So why is it is very important battery estimation in the intelligent vehicle system? So actually the battery SOC estimation, the electric vehicle has the low sufficient efficiency, and also charging time is very long, and charging infra is very insufficient. So that's why we check the battery state of charge. We just abbreviation of state of charge is SOC. So that's why we just have to get the accurate battery SOC. So usually battery SOC estimation method is like using the filter. But in that case, battery model is very important. But battery model is very complicated. But the complicated model is requires huge computing load. So that's why we cannot get the like a real time implementation. So we just reduce the big model, a big like battery model, very briefly, but it has a low accuracy because it's very simple model. So that's why we just design the battery model using the deep learning. So in that case, battery model also has the dynamics. X dot is the state, the function of state and input. So input is current, and the measurement will be the voltage, and it has the algebraic equation. So that's why we designed this dynamics using the deep learning model, the GRU, like one of the RNN structure, and the fully collected layer for the algebraic loop. So we trained this one. And this is the model accuracy compared to the like other battery model. So this red one is my proposed. So as you can see, the accuracy, but this one is not good for that one. So this one, maybe this one, in the case, or this one, and this one. You can see the red one has the the higher performance than the existing model. And using this model, we estimate the battery SOC. So red one is my proposed one, and the blue one is the previous one. the existing result. So as you can see, the existing method has low accuracy, but that one is a little bit. We have a little bit noise, but the page is very has the high accuracy compared to the uh, existing method. Also, we use the AI-based one, the alternative, the observer. So previous research is alternative AI, just to use only this part, but we alternative the AI only big part. In that case, we use the PIN, PINN. It means the physics informed neural network. So physics informed neural network PIN has this kind of structure. So the special one is PIN has the physics uh, dynamics loss of the dynamics loss in the loss function. So we designed the SOC dynamics and the voltage dynamics in here, loss function, and we trained this structure. So I compared lots of methods. The ground truth is real data, real ground truth, and column counting and Kalman filter and data driven is just the use, not the pin, just the using the like a GRU, like a previous method, and physics data is it means we just integrate the physics laws and data laws, and propose is my proposed one. So we just compare all data is like this one. But of course, I already know the qualitative performance is we cannot figure out which one is good for one. So we just check the qualitative result. So CC is column counting, and Kalman filter is Kalman filter, and data driven, and physics data is data driven plus physics base, and proposed one is this one. MAE, MSCE R2 has the performance of the result, and we also check the computing time. So, as you can see in this figure, in this table, our performance is really increased compared to other method. So performance is really increased compared to the CC and Kalman filter and data driven and other one. And then also computing time is other method is really increased compared to the CC, but our method is really decreased compared to the CC. So it means we can develop the higher performance with low computing load to the estimate battery associated estimation. So I finished the state estimation research. And third one is dynamic system modeling, but I know it has the very many research, so that's why I just select three field. So the first driver interaction modeling. So I just repeat the introduction again. So autonomous vehicle require the human-like driving. So we just figure out which factor is affect to the human life. But continuous. We just also want to make the decision-making algorithm. The existing method is already have the database approach and game theory approaches. But the database is depends on the data, and game theory is too many assumptions because the model is very simple. So that's why we just want to make the driver interaction model based on the description of relational agent. Description of relational agent, it is the same as the Newton method, Newton law, for when we describe the physics system model. So when we describe the this field is very popular in the like pork pork theory or like a psychology build. So using that kind of build, we just design the driver interaction modeling. So this is the overall structure I made. Reasoning mechanism and negotiation mechanism is very popular for the other field, sociology or the like psychology like that. But I just adapt into the driving conditions. So we have the mental state. We design the mental state, and we design the plan generation and plan evaluation, and also we design the how to negotiate with uh, other vehicles. So this is kind of very fundamental research. So that's why I just need to validate very various scenarios. So this is the real data scenarios, has the six scenarios. So in six scenarios, we compare to the like a result of decision making using the like a real data and my proposed data. So black one is the real data one, the decision making of real data one, and the blue and red one is my proposed result for LCV and for LKV. LCV means lane changing vehicle, LKV means lane keeping vehicles. So of course I know that the little bit the result is not good. My proposed methods cannot estimate the ground truth well, but the overall pattern is really similar. It means the overall structure, my proposed structure is like a similar to real drivers decision making structure. So that's why if I change a little bit details, we can we can uh, we can get the decision making algorithm like a human being. So nowadays we collaborate the brainwave analysis and this algorithm together, and we want to make the more uh, human-like decision-making algorithm. I also select the traffic system modeling, and then the problem is the okay mega city and population is really gross. Also, the traffic jam is inevitable problem. So that's why we have to like mitigate the traffic jam, the like congestion. The very popular popular solution is we just control the traffic signal. So if we like control, we can control the traffic signal. Okay, we can mitigate the congestion. But the problem is how to get develop the traffic signal model. Sorry. So uh, so we just want to make the control traffic signal control algorithm. So that's why we want to make the uh, model for control algorithm. But so we just want to make the traffic flow algorithm using the queuing theory because the traffic system is like a kind of queuing theory. We have to wait, and we just get the service. That's why it is really resemble to queuing system. So this is the suggested model. So waiting time, we also have the waiting time in the traffic system because of the LED signals. So we just design the waiting time is MN one queuing model. MN is the which model is in the use in queuing model. So M is Markov chain, MN is Markov chain, but difference is N. It's like a state dependent service time, and one is we just serve one by one car. And also we need the assumptions for the queuing model. So the one assumption is like arrival distribution. So we just design the arrival distribution as a Poisson distribution. And second one is like a service time. So service time means when we depart the in the intersection. The service time is designed the exponential distribution. But in the case we put the k, it is the number of the living vehicle in a line. So that's why it is depending on the state. The state is the number of alive vehicle. So that's why we designed the state dependent queuing system for the traffic model. And we also validate my proposed algorithm using the real data set, NGSIM data set, and we design the arrival rate using data set, and departure rate is our proposed method. So the bar is the real graph, real data, and red one is my proposed result. And then this one is arrival rate. So arrival rate is very similar to the real data. So it means we design the model very accurate. Also, we check the departure rate. So departure rate is we compare the lane by lane. So this one is a straight line. It is for the turn right line. So, but in this case, we didn't design the turn right case. So we designed the straight line. So that's why the straight line is the result is very good, better than compared to the real data. But we didn't design the turn right lane, so that's why it's not good, not matched very well. But nowadays we develop the model details, so it means we can design the traffic model like a real traffic system model. So after traffic system modeling, we design the signal control optimal signal control algorithm. So we just want to like more decrease the congestion problem. And the last one in this case, maybe this one is maybe best. So AI based expert skill modeling. So it is actually not related to the intelligent vehicle system. Actually, this is related to the manufacturing. So in the manufacturing, we have a lot of the uh, like a process. For example, like a heat train generation. So heat train generation meant so we in this process we need the expert. So expert has their experience, and they make the heat train based on their experience. So that's why the generated heat train is depends on the expert who make the heat train that make the other performance. But nowadays, the expert is already old, and we don't have any lot of people uh, in the uh, in the factory system. So that's why we designed the deep learning model to generate the heat train. So we just figure out how can I train the expert skill. So first the strategy is we just estimate heat train position using the classification concept. But in the case we just predict the position. So this is the ground truth heat train, the made by expert. And red one is maybe my result. So I designed this problem using based on the classification framework. This is the result. This is the result. This is the result of training data. This is the test one. So training data is trained very well, but the test one is very not good because the lane should be draw the lane, but we just put the position of the pixel. This pixel is the hit right or not. So that's why if the model cannot predict very well, the result cannot draw the line. So that's why we changed the strategy by the regression, and then also we changed the labeling, and then we didn't the line exactly, just we changed to the density and angle, and we estimate this one. So we make the structure like this one, structure like this one. So I just disappear this one because of the time. And this is training result. This one is test data. So compared to the previous strategy, this result is better than the has a high performance. So prediction is like a similar to ground truth, and also test one is really similar to process. So that's why we can estimate the hit rate using the deep learning one. So last one is vehicle control. So because of the time, maybe I will introduce just one topic. So vehicle repeating control for impact. So sometimes vehicle slipped in the due to the loss of adhesion. So it sometimes it spin out. So if we drifting, we can drifting. Maybe vehicle can be controlled. So I want to make the drifting control for the can we get the vehicle push very well in spin out case. So we designed the vehicle model. So that is our strength. And then we also designed the tire model. And we just analyze the characteristic of the model. So we just figure out which one is controllable region, controllable like a equilibrium point for the control. So this one, the blue one is equilibrium point when the vehicle is no slip, no spin out. The red one is the equilibrium point, but the vehicle can be spin out. So if the vehicle spinning out can be controlled into the this red point equilibrium, it means we can control using the drifting. So we designed the drifting control based on the equilibrium point we figure out. And the control algorithm is very simple. The main problem is which point is equilibrium point. So if we know the equilibrium point knowledge, then we can just use the PID control. It's just very simple. So this is the result. The blue one is the like a no control one, and red one is my result algorithm. So when the spin-out is generated into the vehicle, the no controller is like a big slip. And uh, by the way, the red one, our controller can drift very well, and uh, it can control the vehicles into the trajectory I want. So this is the using driving simulator result. So I always say to you, blue one is no control and red one is include the controller. So as you can see, red one draw the trajectory very well compared to the blue one. And we also want to put the into the real hardware. But the problem is we just want to generate the drift. So in that case, we just make the drift case, and then we put the drift controller. But sometimes it's just a mix. So nowadays, we just try to put our algorithm into the real platform. So maybe my presentation is already past 1 hour. So thank you for listening. Do you have any questions?
Thank you, Juhui.
Mm-hmm.
Thank you. There are in seminar early March, Dominic Moyes, the Dresden University, uh,
Mm-hmm.
present the transition in Europe, in Germany, the
Mm-hmm.
energy transition. The idea in the 10 years ago, the people, the academic university believes it's possible to
Mm-hmm.
energy, but now it's a difficult moment. So
Yes, right.
there are gap between your theory and the fact. No?
Mm-hmm.
Now, today, in the morning, Professor Mendiondo, de Sao Paulo University, he's in hydraulic engineering. He shared the problem with the weather, weather in
Mm-hmm.
Brazil, weather in South America, in general, in this climate change. So the projection, the electrical vehicle, uh, no, the new transport, the challenge in this moment is the states, the society, and the energy.
Mm-hmm.
For example, the last week, Venezuela is a big country in South America, uh,
Mm-hmm.
cuts the hours in the work. Why? The lacks the resource, lacks energy. So
Mm-hmm.
the people know the importance, the electrical cars, the electrical ability, but the challenge is how to increase, no, this proposal in this moment, no, in
Mm-hmm.
this year, no. Uh, we live the wars in Russia, Ukraine. We heard about the drones and drones in the army, in the wars. The people in Europe said the military budget will increase. I don't know in South Korea could be the situation, but we live in a different situation 10 years ago or 15 years ago, no? So 10 years ago, 15 years ago, the people very optimistic, no? The new
Mm-hmm.
proposal, the new technology, but now it's a difficult moment. Your research about the new technologies, the new uh, mobility uh, in your experience, no? You are in South Korea, Republic of Korea. You believe this good situation for this technology, or you in your country the state share we need to change the budget, we need increase in this item. I don't know, in different countries say it's difficult moment for the budgets, for the national budget, for the budget for the research, etc. In your experience in your country, what is this situation?
So you want to get information for our like research trend in Korea?
Yes.
Mm-hmm. So actually, and similar to your case, also Korea is very popular, the like electrification and autonomous, both of them. So we have a lot of funding or like a research funding about this one. So that's why I have a lot of topic for the research, for this research. So we just Korea case. Also, we just want to improve the like transportation technique to be the smart and more electrification, uh, change the engine for the energy problem. So that's why we still have the lots of chance to research about this one.
Well, amigos, amiga, Yuji, I would like to introduce Professor Raúl Benítez. Dr. Benítez is director of the Department of Electronic Engineering in San Marcos University. Profesor Dr. Benítez, ¿nos escuchas?
Sure.
Yeah. Raúl,
Okay. So,
well,
do you have any
amigos,
questions?
¿tienen preguntas? ¿Tienen comentarios? Pueden compartir en el chat.
Buenas noches. Good evening.
Sí.
Yes, I have a question. Are machine learning or deep learning techniques being used to improve leader noise filtering? Is the question.
Oh, yes. Sorry, one more again, please.
Are machine learning or deep learning techniques being used to improve leader noise filtering?
Yes, right. So I also adapt the deep learning or kind of the lots of technique for the like a filtering.
Okay. How they compare to traditional signal processing methods?
It depends because as you know, the actually AI technique is depends on the like database. So that's why the if the small snow or small amount of the noise, the deep learning technique is more accurate. But if we get the like a huge snow particle, it at that case the deep learning technology doesn't valid anymore. So that's why in the case the traditional method is already strength. So that's why I just want to make the like a method collaborating the traditional and AI both of that.
Okay, thanks.
Yuji, for example, when is the time to apply for the postgraduate, the master program in your university, for example, for Hanyang or any other student, no? In last year or early year, what is the time to apply for the master or doctorate program in your university?
You mean the like my student?
For the foreign student.
For any student? I don't know details. Just for example, my lab is actually my lab. It has a lot of students. The mass, but I don't know the other ones. So, but we just maybe nowadays the students want to go to like a master or PhD.
In general, for example, in states, start the application to October, no? Or in Spain, start the application in January, no? It's different, no? In Europe or North America. Yuhui, what is your experience with the South America University or Latin American University or Latin American student? What is your experience, your contact?
You mean the abroad student?
Yes, you have foreign
Yeah,
students.
I have lots of foreigner students contact me, like for example, even America and also the like Pakistan or India or Venezuela, like not Venezuela, like which one? Bangladeshi. Yeah, but unfortunately, also China like that. But unfortunately, there is no foreigner student in my lab. But other lab has a lot of foreigner students.
Well, this moment, for example, some Latin American country is increased economy, strong networks. For example, Peru this year start Port North Lima in Chancay. So our contact with Asia, East Asia increased in this year in the, in the projection. So I believe the president from your university start this academic agreement so your university think develop activities with South America, with Peru. In this area, the research of your laboratory is very is connect with our projection in Peru in the increase the electrical mobility and the intelligent artificial. So we can see more activities within our university, our institution. Do you know South America? Do you know Peru?
Yeah. I know that. So also, yeah. So maybe I prefer. I just want to the like a global research together. So yeah. Also in Korea, we have a lot of global. We also very important for the global communication. So always welcome. But actually, I'm not a uh, like a document paper like a professor. So just for the researcher. So like a researcher. So that's why I'm not interested in the like a trend of the like a Korea one. But always welcome for the research.
COICA, the International Cooperation of Republic of Korea, has a long tradition in Peru, COICA. So we
Ah, yeah,
can,
quicker. Yes.
a student from engineering, political science, medicine, usually takes 1 year in Peru, not only in capital. In,
Right.
so
I know that.
this tradition, this contact in Peru and Korea could be developed, could be increased with universities, South Koreans in Peru.
Okay.
This year we start activities with the INA University. INA is in Cheon for the Sumwon. And now your university, Cheongwan, is the south of Korea, in the coast. And your research is part the new economy. Your research is part of the new proposal in new society in 21st century. Not only for the academic, for the countries, for the states, it's very important. So we can sing, continuing this connection with virtual, then physical presence.
Sure, it's good. Yeah.
Bueno, amigos, amigas, ¿tienen algún comentario, alguna pregunta? Juhui, I read your website, the website, your laboratory. I read about the members, the student, the doctorate, the master, and the undergraduate student. You have a wonderful team.
Thank
Not
you.
the men's, but the women's engineering. So I think we can project activities with your students, virtual activities. They can share his experience with our student in this that learning, artificial, new technology.
Yeah, it's good. If it is good, yes, I'm always welcome.
There are 14 hours, no, between Lima and Changwon. Yes, it's a distant city, distant country, but I read your city, no? Your city has a friendly connection with the Latin American city.
Right.
I read the international sister, Viña del Mar, Chile, Zapopan, Jalisco, no? Latin American city has contact with your city, no? Changwon.
Mm-hmm.
Changwon
Mm-hmm.
has contact with the Latin America.
Right. So also we are very, yeah, have a good image for the Latin America. So always welcome in Changwon. Of course, I know that it's very far, but yeah.
Well, you are very young professor, you're very young
Mhm.
researcher, but at the same time, you have experience in this area, and it's nice to meet you, nice to start activities within our university with you. Our university celebrate next May 474 years old. So you are part in our history. You will be the first professor in this contact with our university.
Okay. Just
Well,
yeah, already invite me.
bien. Faculty de Electronic and Electrics has a journal. This journal has 2 volumes per year. Could be opportunity the journal to connect our university, our academics departments. No? I can, no? Your members, the laboratory, can apply to publish in our journal. So the idea is to think how to help the people, help the society, and the other is the question for each professor, the different universities is how connect your research with your community. No, is the projection that this laboratory for your local community in your city, for example. You are in contact with the municipality, local authorities to change the law for these new technologies. It's difficult, the dialogue between university and the local authority. In your experience, is distance between local authorities and university, or really is a contact between local authorities and university in this topic, no, in these new technologies?
Sorry, I cannot hear you. So can you repeat again, please? Sorry about that.
What is the relationship between the academy, university, and local authorities about new technology, for example, the research of your laboratory? There are
So yeah,
connection.
yeah, we have like a very good connection. Actually, Changwon is very popular for the like not automotive and smart manufacturing. So that's why we are very big relationship to the university and the company together. And that's why I just also working here. And yeah, also we are the very like a global city, so that's why we want to like collaborate the research together. He attached it, so that is what I know that.
Finally, what is the uh, model, the experience model for your research? So, could be in Japan, could be in South Korean city, could be a city of China, could be the model for your research, no? The model in assimilation, this new technology, this new transport, electric transport, and
Yeah,
how.
actually, the export model, you mean the export model, right? The export model is actually related to the Korean company, so that's why I just about that research valid in Korea. But I just can get the expand to the global, like Japan or other countries.
Well, amigos, amigas, les hago presente un gran saludo por su presencia y asistencia. El día de mañana nos encontramos temprano con Almendra Villalta. Almendra Villalta desarrolla su doctorado en Gante, Universidad de Bélgica, en lingüística. Juhui, thank you very much for your time. Thank you very much for your help. It's a first step in a long way in our countries, university, and communities. I hope that you can visit Peru in the future. We can project new activities. Yes, this is take time, no? Connection between university, but this is very important for the communities, for the society, no? To help in new technologies and new opportunities. So I hope that the next year could be a student to apply for your master or your doctorate program.
Okay, when you guys, when you want to me collaborate research together, just let me know. Always welcome in email. Okay, thank you for inviting here.
Amigos, amigas, ¿pueden prender su cámara para tomar una captura de la sesión, por favor? ¿Pueden prender sus cámaras? Please, Yuhi, for the take a picture. Amigos, amigas, ¿pueden prender sus cámaras para tomar una captura de la sesión? Un momento. Ya. A ver, uno, sí, pueden prender sus cámaras. Muchas gracias. A ver, uno, dos. Okay, well, thank you. Muchas gracias.
Thank
Y
you.
muchas gracias.
Thank you. Bye bye.
Okay, bye.